Okay, last video for tonight. I have another problem. I have here this rather unusual looking shape. It sort of looks like a wedge. Try to have you see it in 3D. It looks like a wedge. It's wide here, comes down to this narrow point right here. And I'm given some dimensions. I'm told that it has a height here of 9, has a length here of 12, and that the diagonal from this top left, if you like, looking in this direction, top left to this bottom right, is 25. That I'm given this diagonal. I'm also given that I have a right angle here, and I have a right angle here. So this question is quite nice. It tells me what right angles I have. And I'm asked to solve for this side length, this distance here, x. Okay, at first you might think that this is a slightly more difficult problem. Maybe it seems more intimidating, but it's actually, I think in my opinion, is a little nicer. Because I immediately can see that I have triangles, 1 and 2. And I know that in order to solve for x, I need to know 2 of the sides of this triangle right here. It's this triangle. I don't have that. I don't have this distance here, so I can't solve for x immediately. I need to find this distance. Luckily, I can find this distance here because with this right triangle, I do know 2 of the sides. If I know 2 of the sides of a right angle triangle by Pythagorean theorem, I can find the third side. So that's what I'm going to do right now. Okay, so let's call this side length, let's give it a name, let's call it y. And let's write down the Pythagorean theorem. The theorem says this triangle that 9 squared plus 12 squared is equal to y squared. 9 squared plus 12 squared is equal to y squared. That gives me 81 plus 12 squared is 144 is equal to y squared. 81 plus 144, if I do that quickly in my head, that's 225. So that is 225 is equal to y squared. It follows that y is therefore the square root of 225. Put that into your calculator and you will get a value for y of 15. So y is 15. Square root of 225 is 15. And so I can fill that in here. I have y is equal to 15. And now I have this side length here of 15. Okay, it remains to just solve for this distance x. I have a right angle triangle, and now I have 2 sides. I know one side length is 25, that's the long side, and I know I have this side length 15, so I can solve for x. Setting up my Pythagorean theorem again, I have, therefore, just put a line here, I have 15 squared plus x squared is equal to, that is 25 squared. So that is this triangle, applying the Pythagorean theorem to this triangle. 15 squared, well, we know that's 225, we just had it. So that's 225 plus x squared is equal to 25 squared. 25 squared happens to be 625. Look that up in your calculator. And so now I can solve for x squared at least. X squared, subtracting 225 from both sides, this equation will become x squared is equal to 625 minus 225. 625 minus 225, that's 400. And so I have a value of x squared equal to 400. That tells me that x, therefore, is the square root of 400. The square root of 400 is 20. And so I have here that this value of x is 20. And that's it. Those numbers worked out quite nicely for us. And again, you see that there's nothing more to this than just the correct application of the Pythagorean theorem. That's what you're doing. You're looking for right triangles, making sure you identify which side goes where in the equation, and applying it on this occasion twice to be able to get our answer. That's it. Okay, hope this was helpful.